Hey students, how are you all? Welcome to IMS online classes. Okay, so I'm sure today also you might be eager to know what you're going to study next. Now in the last video we studied about chemical properties of metals. In this video we are going to study about some of the chemical properties of nonmetals and uses of metals and nonmetals. So mostly regarding the chemical properties of nonmetals, we'll study about the electronegative character, then we'll study the reaction of nonmetals with oxygen, then reaction of nonmetals with halogen, reaction of nonmetal with hydrogen, and also reaction of nonmetals with acids. Okay, so are you guys ready? Okay, so let's study what are the different chemical properties of nonmetal. First is electronegative character. Now, recall that when we are studying about the physical properties of nonmetals, we said that nonmetals are substances which are electronegative in nature. So let's know what does this means. Electronegative nature, it means they have a tendency to accept electrons and form negatively charged ions. Negatively charged ions are called as anions. For example, chlorine. The symbol for chlorine is Cl. Okay, chlorine, it accepts one electron and it forms chloride ion, Cl minus, negatively charged. Similarly, oxygen, it accepts two electrons and it forms oxide ion, O minus 2. Okay, so generally all non-metals, they are formed negatively charged ions except for one, that is hydrogen. Okay, hydrogen, it can form both negative and positive ions. It can accept an electron, okay, or it can remove an electron to form hydrogen ion. It will remove and it can put positively charged. Okay, so it can accept an electron. It can become hydride ion also, but on the other hand, it can also release an electron to form hydrogen ion, a positive ion, cation. Okay, so this is the electronegative character of a nonmetal. Okay, reaction with oxygen. Now, nonmetals, they react with oxygen to form covalent oxides. Covalent oxides in the sense that is the oxides which are formed that can be either neutral or acidic. Okay, sometimes a nonmetal forms more than one type of oxides with oxygen. Okay, for example, if you take nitrogen, nitrogen forms 5 different types of oxides. Okay, if you take 2 molecules of nitrogen and react with 1 molecule of oxygen, we will get nitrous oxide, that is 2N2O, which is neutral by nature. Okay, if you take 1 molecule of nitrogen and react with 1 molecule of oxygen, we will get nitric oxide, which is also neutral. Now, if you take 2 molecules of nitrogen and react with 3 molecules of oxygen, we will get dinitrogen trioxide, which is generally acidic in nature. That is, the formula is 2N2O3. Then, if 1 molecule of nitrogen reacts with 2 molecules of oxygen, then you get nitrogen dioxide, which is also acidic in nature. Okay. Similarly, if 2 molecules of nitrogen react with 5 molecules of oxygen, we will get dinitrogen pentoxide. Okay, this is also acidic. And when this dinitrogen pentoxide, if you dissolve this in water, it forms nitric acid. Okay, so acidic oxides, when dissolved in water, it forms corresponding acid. Okay, let's move to the next example. Now, moving on to the next example, that is carbon. Carbon, it also reacts with oxygen and forms 2 different types of oxide depending upon the availability of oxygen. If less amount of oxygen is present, then carbon reacts with oxygen and forms carbon monoxide, which is neutral in nature. Okay, and if excess amount of oxygen is present, then 1 molecule of carbon reacts with 1 molecule of oxygen to form carbon dioxide gas. Okay, carbon dioxide. Okay, this carbon dioxide gas is generally acidic in nature. So if this oxide is dissolved in water, it forms carbonic acid. Similarly, for phosphorus also, it forms 2 different types of oxides, but in this case, both the oxides are acidic in nature. Okay, if phosphorus gets limited supply of oxygen, that is 4 molecule of phosphorus reacts with only 3 molecules of oxygen, it gives phosphorus trioxide. And if excess amount of oxygen is made available to phosphorus, then it forms phosphorus pentoxide. And both these oxides are acidic by nature. That is, if you dissolve in water, both will be converted into acid, phosphoric acid. Okay. Then for sulfur it also forms 2 different types of oxides, and both these oxides are acidic by nature. Sulfur, if it reacts with only 1 molecule of oxygen, it forms sulfur dioxide. And this sulfur dioxide, if you add to water, it forms sulfurous acid. And if 2 molecules of sulfur reacts with 3 molecules of oxygen, it forms sulfur trioxide. This sulfur trioxide, if it is added to water, it forms sulfuric acid, one of the most dangerous acids. Okay, so these are the different type of oxides formed by nonmetals. Okay, now moving on to reaction with halogens. So next is reaction with halogen. Halogen are type of compounds, those are present in the periodic table in the group 17, or mostly you can say the halogen group includes fluorine, chlorine, bromine, iodine, such kind of substance. So let's see how nonmetals react with those substances. So generally nonmetals react with halogen to form corresponding halides. Okay. For example, if you take phosphorus reacts with chlorine. Okay, it needs heat. If phosphorus is heated in presence of chlorine, it forms phosphorus trichloride, that is 2PCl3. Okay, and hydrogen, if it reacts with chlorine in the presence of sunlight, it gives hydrogen chloride. Similarly, if sulfur reacts with fluorine, okay, but it needs more high temperature. Okay, under high temperature, if sulfur reacts with fluorine, it gives sulfur hexafluoride. So these are different types of halide formed by nonmetals. Then is reaction with hydrogen. Okay, generally nonmetals they react with hydrogen to form corresponding nonmetallic hydrides. Okay, for example, if you see hydrogen, it reacts with sulfur to form hydrogen sulfide. Okay, H2S. 3 molecules of hydrogen reacts with 1 molecule of nitrogen. Okay, it reacts with 1 molecule of nitrogen to form ammonia. Okay, which is used as a fertilizer. Then hydrogen also reacts with oxygen to form water. Now, one of the most interesting fact in this thing is that hydrogen sulfide is weakly acidic by nature. Okay, ammonia is basic by nature, and water is neutral. So you can say hydrides, they form all the different types of substances. It can form the hydrides can be acidic, basic, or also neutral. Understood? Good. Next is reaction with acid. So next is reaction with acids. So nonmetals, in the opposite of metals, unlike metals, nonmetals, they do not displace hydrogen from the acid. Okay, because they accept electron rather than releasing an electron. So that's why they cannot displace hydrogen from dilute acids. So generally they don't react much with acids, but some nonmetals they react with some kind of acid, some concentrated oxidizing acids to form oxyacids. Okay, for example, sulfur. If you take sulfur, it reacts with nitric acid to form sulfuric acid, nitrogen dioxide, and water. Okay, so they form corresponding oxyacids when they react with a concentrated oxidizing acid. So this is how nonmetals react with acid, and these are the different type of chemical properties of nonmetals. Okay, so if you want to note the properties, you can pause the video in the middle and you can note it down. Now let's move on to the uses of metals and nonmetals. So now let us see some of the uses of metals. Okay, metals based upon their physical and chemical properties have lots of uses, but here in this video we'll discuss only about few of them. Okay, first, iron. Like I have already said, the current era is the iron age, right? So most of the things we use is made up of iron. So iron is mostly used in construction, in making engine parts of various engines. Iron sheets are used to build anything. Then it is also used for the manufacturing of steels. There are a lot of things. Okay, in a lot of things, iron is used. Similarly, copper. Copper is used in the electric wires. As you can see, the wires through which electricity is carried, it is made up of copper. It is also used for making utensils. Then it is also used to make coins and to construct different alloys. Similarly, silver. Silver, most commonly it is used for making jewelries. So in some parts they use it to make utensils. It was earlier, at first, it was used for photography. Okay. Then now it is also used for the converting a glass into a mirror, or it is called as silvering of mirrors. Similarly, gold. Gold is also a metal which is used for making jewelry, as it is very much shiny and non-reacting, right? So it is used for making jewelry. Next is aluminum. Sorry, mercury. Mercury is used in thermometers and barometers to measure the temperature and pressure. Next, aluminium. Aluminium is also one of the widely used metals. It is used in wires, it is used to make cables, then it is used to make utensils and for different alloys. And as I have said earlier, aluminium foils are used to store food in them. Then lead. Lead is used in automobile batteries, okay? In automobile batteries. Then also it is used as the protective screen for X-ray machines. Okay, so these are some of the common uses of some few metals. Okay, few metals. Now let's move on to the uses of non-metals. Now next is some uses of non-metals. Okay, non-metals are used for various purposes depending upon their physical and chemical properties. But in this video, we'll discuss only few uses of some non-metals. First is carbon. Carbon is one of the most abundantly found non-metals. Okay, it has lots of uses. Some major uses can be said. Carbon in the form of diamond is used for jewelry. Then diamond is also used for cutting glasses. Then in the form of graphite, carbon is used in the pencil lead that we are using. Then a form of carbon called coke is used in producing steel. Okay, so these are some uses of carbon. Next, sulfur. Sulfur is used as used in manufacturing of gunpowder, sulfuric acid, and so much. Phosphorus. It is an important source of fertilizer to plants. It is used in fertilizer industries. It is also used to make the safety matchsticks that you are using at home. The red portion is called as the red phosphorus. Okay. Then it is also used for rat poison, making rat poison. Oxygen. Next is oxygen. One of the most important non-metals, right? Because every living organism in this world needs oxygen to survive. Okay, so it is used as respiration, process of respiration, and also it is needed in the process of burning, that is called as combustion. Nitrogen. Nitrogen, it is used for the manufacturing of ammonia, nitric acid, and etc. Then chlorine. Chlorine is used to make bleaching powders, to sterilizing water as disinfecting agents. Okay. Then hydrogen. Hydrogen is used as fuels, okay, to generate more power, and it is also used to manufacture vegetable ghee. Then iodine. Iodine is mostly used in salts to make the salt iodized. You might have seen in various advertisements about salts, they said iodized salt. Okay, iodine is also one of the most important minerals needed by our body. So these are the some of the uses of common non-metals. Okay, so I hope you understand everything. Do pause the video and note everything. Okay, and have a nice day. Thank you.